So let's take a look at this example again. I drew a more accurate picture where this is our original region down here, and it's rotated around the line y equals 6. And if you notice, it's going to form a whole bunch of washers, that this inside part is just going to be empty space. It forms an empty cylinder on the inside, whereas the outside is going to be sort of this curved region. So our goal then, we identify that if we divide this up into pieces, we're going to be integrating with dx as our variable, and each of these washer regions is going to have an empty center and a larger outside. So let's identify the radius of those two things. The radius of the inside part is actually easy in this case, that our little r is a constant value of 3. And I know that this inner r, I guess maybe it's better to look down here, our inner r is going to be exactly equal to 3 because it's the difference between 6, our line of rotation, and 3, the maximum value of this region. So our little r is equal to 3. And then what is our bigger r? That's a bigger question. Our bigger r is the r that extends all the way to the edge, and we need to know, what is this distance? Well, if our big R extended all the way down to the x-axis, our big R would be equal to 6. But it's not quite that long, right? Because we don't go all the way down to the x-axis. We're going to stop when we hit this curve. So what is that distance total? It would be the whole distance 6. But I want to stop when I hit the curve. And what is the height of the curve there? The height of the curve is actually 3e to the negative x. And that means that the outer radius is going to be 6 minus this little sliver in here. Now that we have our two radiuses, the rest of this is actually pretty easy. We just use the fact that what is the area of one of these circles? Well, the area of a circle is just pi r squared. So the area of the inner sphere is going to be given by, maybe I'll write that down. Remember our formula that for washers, we're going to integrate with our big radius squared minus our smaller radius squared with respect to whatever our integrating variable is. And we identified that our washers are going to have width here of dx. So I can plug these values in, and I see that I'm going to integrate what are the bounds on my x values. In this case, my x goes from 0 until x equals 4. That was something given in the problem. My big R squared is given by 6 minus 3e to the negative x, all squared. And my little r squared, oh, pi. Sorry, this is something that is important to not forget. It's the area of a circle. It's not just r squared, it's pi r squared. My apologies, guys. So this was our big radius, and that's why it's first, and I'm going to subtract out the smaller radius, which is just 3 squared. So that was the hard part, setting up the integral. And if you'd like, you can pause. Otherwise, let's go ahead and compute this integral. I'm going to multiply out, so this is our function. I'm going to multiply that out. Don't forget the middle terms, that this is 36 minus 2 times 6 times 3. 6 times 3 is 18, times 2 is 36, e to the negative x, plus 3 times 3 is 9, e to the negative 2x. So this really is, I'm foiling essentially in my head. I'm using the distributive property with these two terms. And I did a lot of this work in my head. You can verify that yourself. And then I'm going to subtract out 9 for my smaller radius. And there's one piece that can simplify. And I'm going to break this up into 3 separate integrals because I have 2 different u subs that I'm going to need to do to be able to solve this. So this is pi times the integral from 0 to 4. Our constant term is going to be the easiest term. This is 27, right? Yep. 7 dx minus pi times 36 times the integral of e to the negative x dx from 0 to 4 plus pi times 9 times the integral of e to the negative 2x dx from 0 to 4. Why could I break this up? I can only break it up because it's separated by a plus or a minus sign. If it were a product multiplied together, I couldn't just break it apart. The first integral is something easy. This is pi times 27 times 4. 25 times 4 is 100, and I have 3 left over, so that's 112 pi. But for this next integration, I'm going to do a quick u substitution. It's an easy one that you can almost do in your head. If I let u equal negative x, it means that du is going to be equal to negative dx. So I have to multiply this whole thing by a minus sign when I integrate, giving me, maybe I'll write it down here, so these lines aren't going to line up, plus pi times 36 times, so if my u is negative x, I'm integrating e to the u, du, and I'm taking care of the negative sign by making this a plus, where my bounds are still in terms of x from 0 to 4. I'm lazy, I don't like converting my bounds. I just keep them in terms of x and then I'll convert back later. Similarly, we're going to do a u sub where u is equal to negative 2x for this one, and so du is going to be equal to negative 2, so I'll have to multiply by negative 1/2 for this one. So 9 times negative 1/2, integrating from 0 to 4, e to the u du. So my first term is 112 pi, that just comes along for a ride, and then I'm going to add pi times 36, and e to the u integrates to be e to the u. I'll plug my x back in and get e to the negative x evaluated from x equals 0 to 4, and I can do the same thing here, so this is minus 9/2 pi, e to the u again I'm going to plug in and get negative 2x evaluated as x goes from 0 to 4. I'm doing some of the work in my head. The integral of e to the u is just e to the u, and then I plug the u back in to evaluate. And this gives me 112 pi, and this becomes plus 36 pi times e to the negative 4th minus e to the 0. We have to include e to the 0 is not 0. E to the 0 is equal to 1. That's a common error that I see all the time. So this is my thought bubble reminder. So now you'll never make that mistake, right? So e to the 0 minus 1. And for the final term, I get minus 9/2 pi times e to the negative 2 times 4 becomes e to the negative 8 minus 1. And I could plug that into a calculator to simplify if I wanted. It's not pausing.